But guys, without further ado, I do want to hear close on what Bar has to say, as we said, related to AppSec in the DevOps world. So, Bar, you have the control. See that it's working. You can start.
All right. Let me just see that I can move it. All right. We got it. So I won't add more about myself because Lior was so nice to already explain most of it. And, you're not here to learn about me. You're here to learn about securing the SDLC pipeline. So we'll get right into that part. I just want to give maybe a very quick brief. We're going to talk about to give a bit of a background first about what is DevOps, what is AppSec, and then how they come together. So I expect some of you already know those things, but I learned from my experience that building a strong basis in the of information, of understanding, usually helps understanding deeper subjects. So that's where we were going to go. So we're going to start with the era of pen testing. Before CI/CD, before DevOps, before automation, we had, or in the before times, as people usually call it, we had the waterfall. Waterfall basically means that everything flows in one direction. This is a slow process where when we developed solutions, and I think that most of you can remember, we don't need to think that much back. Think about, let's say, Adobe Photoshop. Before they had a cloud version, each year or 2 years or 3 years, you had a new version of Photoshop coming out and everyone was very excited. Think about Microsoft, Windows, right? So we had Windows 25, 28, second edition. It took a lot of time for each new product to come out to the market. And this is because most of those things worked with a waterfall, not continuous release cycle, like we're used to today. So waterfall basically means, releasing between every 8 to 12 months release cycles. When we're talking about security, then, you have time to do penetration testing, you have time to do full security. You can take a team that has a lot of time in their hands to go through each and every part of the application of the solution that you want to take out. And even then, things can go wrong, right? And if they do, we get, again, a very long cycle between the finding of the vulnerability and the patch coming to you, right? Think about big and critical severity items. In waterfall, those can take 4 months, 5 months. Think about your D-Link, your routers in your homes. When did you update them last? Right? No one updates them. If they have a critical vulnerability in them, it takes a lot of time until they get any kind of updates. And this is how it was for everything. But there was an upside. Even with all of that, there was an upside, and that is that security was in sync with development speeds, which means that at least security could say, all right, we did our best evaluating the solution, the product that you're going to put out there, and from the best of our understanding, it should be fine. But then, the world progresses, and we thought, we need to release quicker. We don't want people to wait half a year for a new feature. We want to push more software. We want to get features quicker. We want to update things, right? When we have bugs, even not security related, we just want to develop quicker. And this is why today most of the software that you use is using either a continuous release logic, like if you're using Windows, then every 2 days you have a new patch to update, you have a new Windows updates coming, your phone, rings and says, I have an Android update that I need to do, because everything is always flowing forward. Now, that sounds good, right? So this is where we brought DevOps. Now, what is DevOps? So DevOps is the idea of bringing infrastructure and operations and IT and all of the not really R&D helpers to the R&D, and allow those two teams, the development and operations, to work together in a continuous cycle. For those that were not developers 10 or 15 years ago, a lot of time was wasted for things like, hey, can you allow this port to be opened on this VM that I need to set up? Can you increase this memory? And those things took time. And you can't develop quick when you need to wait 2 days for someone from IT to get an email and respond back to you. Now, this is just part of it. A lot of emphasis on newer DevOps approaches is also to do a continuous learning. So monitoring, planning, releasing, testing, deployment, monitoring, planning, coding, building, and all of that. You can see the figure 8 flow. And it's really like that. We just want to do a continuous, endless flow. We get improved development frequency, faster time to market, lower failure rate, shortened lead between fixes, and faster mean time to recovery, right? Because we can fix things quicker. And of course, the other things like improved collaboration between operations and development. It increases the efficiency, and everything that increases in efficiency reduce costs, right? There is a very focused look at automation, which again saves money, saves time. All of that sounds amazing. Customers happy, we're happy, more money for the customer, for the company. Everyone is great. Sounds amazing, right? What can be the problem? If before DevOps, we looked at something between 8 to 12 months or between each release, now we're talking about each release or each build every 2 or 3 minutes. Some companies go quicker, some companies go slower, but usually we're talking at least a few builds a day. And when that happens, even the best penetration testing team out there can't follow up on that. Think about doing a full penetration flow. That's usually something like 2 weeks of work. Going through the application, finding all of the vulnerabilities, creating a report, making sure that the developers get this information and act on it, and then verifying all of that again, right? This process takes a lot of time when it goes manually. And if we're talking about a build every 2 to 3 minutes, and we have 24 hours because, part of the company is in Europe, part of the other part of the company is in the US, and it all connects to one big workflow, it means that we need to pen test 720 builds a day. Obviously, that's not humanly possible, and we need more people, right? So maybe that's how we solve it, right? Can't we just hire more people? No. The reason we can't just hire more people is that there is just a very large imbalance between developers and security professionals out there. For each, for every 500 developers, there's one application security expert. And that means that there is just no way that we can even get to a situation where those numbers adds up, right? If my team has 99.8 developers, there's only 0.2 AppSec professionals in it. And that's for a team of 100 people, right? So in 100 people's team, there isn't even one AppSec engineer. So there's a growing demand. More companies need more AppSec, more people, more penetration testing. Our application gets bigger, more complex. There's more things to test, APIs, GraphQL, REST, all of those things create a larger and larger attack surface. And we're just getting deeper and deeper into the mud. What do we do? Security had to learn to sprint. Basically, going from shoveling everything that DevOps does and running after them, we're moving into sharing the concept of security and security processes with the DevOps cycle. Now, this might seem a bit weird. Aren't we just throwing the responsibility on someone else? But not exactly. So what we're aiming to do here is to say, all right, we have DevOps. We have those practices, those people that are very strong with automation. They are already integrated a lot of tools, a lot of smart processes through the development. Can't we just take this line of thought, this CI/CD pipeline, this new SDLC concept, and share security with it, right? Inject some security into it. So we're talking about security here, security, the actual security, but what's that security, right? Security is a very large word. Usually when we talk about security in the pipeline or security as part of the application development, we're talking about something called AppSec or application security. Right now, and this is based on Verizon's the year 2023, 2023, research, more than 80% of breaches happens due to web application issues, right? Now, when we're talking about applications or even more specifically web applications, right? This is the main place where companies and organizations get hacked from, right? If you look at the amount, you would thought that most of those would be some very complicated 0 days or some tricking people, going through all kind of emails and malwares, but no, the basics. Basically, you're right. Now, the main problem with web applications is the basic tests. And again, this is what we see from Verizon's the Bureau's research. Basic web attacks are still the most major attack vector when looking at compromising applications. And everything we do today is application-oriented. Your phone, those are applications. Your phone talks to some REST API server that runs somewhere, and that's where all your data is. Your smart cameras, centralized servers, your smart car, your cryptocurrency, everything that we work with, we do is application. All right, so we define that security. We know that we call it AppSec. We define the DevOps. Now, how do we actually integrate them? Because DevOps and AppSec works beautifully together, right? We are securing the SDLC. We have quicker cycles, which means quicker fixes. We have automation, and we can find issues early on. Looks amazing. This is DevSecOps. And the idea behind introducing security into that DevOps cycle or DevOps concept. If you see, it looks very similar, right? We didn't change anything in the DevOps flow. We're just kind of blanketing all of that with security in mind, because that's the idea. We want to keep it simple. So DevSecOps is just an extension of the DevOps philosophy, and it means integrating security practices into the already developed DevOps cycle, right? So when we code, when we plan, when we build, when we test, when we do the releases, when we do the deployments, when we do the monitoring, each part of that should also have a counterpart which is security oriented, right? So when we're doing planning, we do security planning. We want to create a new feature. We want to implement, let's say, we're creating a new web application. We're going to have a chat interface. All right. What risks could this chat interface bring? Is it LLM based? Do we have LLM issues? Is it reflecting the text that we're putting in? Can it be used for XSS? Does it save the chat into a database? Could there be an SQL injection problems there? So each part of the planning should also take security into consideration. All right, we wrote the code. Now let's scan it. Let's test it. Let's use static application security testing. Let's use SCAs. Let's make sure that what we wrote is actually verified. We're building. All right, so this is container security, packages. We want to make that sure that everything is fine. Tests, right? So tests, let's use dusts, web scanners, whatever we need to make sure that runtime is also working. And this way, in each part of the DevOps cycle, we have some kind of automation that is AppSec oriented or security oriented and just enhances the whole prospect. So what are the key principles of DevSecOps? First is shift left security. This is something that a lot of people are talking about, but what does it actually mean? So shifting left means bringing security closer to the developer, right? Shift right, or the right side is production, the left side is developers, right? The code. And we want to bring security as much to the left as possible because that allows us much quicker iterations. Think about the difference between writing a line of code, finding a vulnerability there, and then fixing it directly there, instead of finding the vulnerability in production and then needing to figure out why it's in production, who wrote it, which part of the code was responsible, and you just need to reverse engineer your steps until you figure out where it was. So understanding or getting those alerts, notifications, findings as left as possible or as early as possible gives us a lot of advantages. Automated security testing. Now that we have the ability to integrate into the CI/CD pipeline, into the SDLC lifecycle, it means that all of those automated tools that DevOps added to the development process can now be used for security. Not all of them, but we can add tests, tools, and security automation concepts into the SDLC. So things like SAST, SCA, DUST, all of those automated tests can now be run inside of the CI/CD cycles, failing, letting it pass, depending on what we configure. And of course, empowering developers. Now, in the sense of empowering developers, we want to make sure that the developers can be self-sustaining in regards to security. You're a developer. You're writing your code. You know how to fix your own bugs. Why can't you fix the security bugs? In the end, security issues are just bugs. Maybe they have a different category, but they are bugs in the code. Someone can do something that was not expected, or your application behaves in a way that you did not think about. This means that you as a developer can now understand what has happened, because you got training, because you went through the planning, because you got notification about finding it very early in the process, and now you as a developer can take care on own security, which is a very cool concept. So the classic DevSecOps paradigm basically looks like that. So in the development stage, we're doing static application security testing, or SAST, which means running through the code with an automated solution and look for vulnerabilities. We have open source verification, or SCA, software composition analysis. I'm sure that a lot of you are using those without even knowing. So I'm sure you all know what dependabot is, or you updated or installed NPM packages, and then suddenly NPM said, those packages has critical vulnerabilities. That's SCA, or Sneak, or any other of those vendors. Security training, because we wanted to put the security already in the design or planning stage. So we want to make sure that developers know what to look for or how to think, right? Because it's a mind shift. We're not just thinking about functionality. We're now thinking about security in that concept. Now, in the CI/CD itself, we can run container analysis. We can run infrastructure as code testing. We can do all of those tests and checks, even SAST and SCA, but inside of the CI/CD build. So even if it didn't run on the development flow, at least it runs in the CI/CD itself. And post-build, we can do things like full web security analysis. So a DAST solution, we can run vulnerability assessment and if needed, we can even do penetration testing, but either automated or after splitting our lanes into a fast lane and comprehensive lane, we can say, what, this is the major build. All of those are just small fixes. We will do manual penetration testing on this very large generic build, and on the small changes after code freeze or whatever, we will only do automated testing. So this gives us a lot of options and a lot of capabilities on how do we plan our SDLC and how do we want to plan our development cycle. Now, when we're talking about AppSec or AST, which is application security testing, we have, I would say, 4 main tools out there, but let's talk about 3 of those. So one which isn't here is SCA, the source code analysis, which we talked about before, the software composition analysis. Others are SAST, which looks at the code and finds vulnerabilities in the code. We have DAST, which is automated web scanner. So basically scan the running application and get information, get results, and get which request, payloads, etc. we found. And IAST. IAST is interactive application security testing, and it basically supposed to be a combination of those 2 concepts, but we're going to talk about it in a second. So SAST is aimed mainly at developers. It runs in the IDE, it scans the code when you're doing your coding phase. The pros, of course, are early detection, but the cons is that SAST solutions are usually blind to the full picture. Because today's software is very microservice oriented, and a lot of the code that we work on are very small and very small pieces, and sometimes we can't get the full context of which requests come from where. Is this an internal API, an external API? Does the user have access to this? Is the information that I'm getting already escaped or not? Is the data, I don't know, flowing internally? We don't know how to answer all of those questions or provide SAST solutions with all of this context, because it just looks at the code, not the runtime. Then it has a lot of false positives, and also it needs to do a lot of guesstimations based on a lot of information. Then we have the DAST approach. The classic DAST usually looks at security or AppSec people, and you should run it in the testing or staging phases. So the pros is it has full view because it scans the run live application. So all of those microservices and little functions are already all combined, or all of them are in the same flow. And it looks at it like an attacker would. The cons is that it needs a live target. Why is that a con? Because if we're talking about automation and we're talking about running stuff in the CI/CD, not all situations allow us to actually start a full environment inside of the CI scope. Some places we can do that, especially if it's just a standalone microservice. We can do Docker Compose, we can automate the deployment into a Kubernetes pod, or we can just, run something locally and then test it locally. But if our application is very complex, it has like 20 microservices that needs to run in the same time for it to be operational, then obviously that's not something that we are going to do inside of the CI. And so in those cases, that would be either a post-CI or a post-deployment or pre-prod, and you will need to think like, how do I actually position it? IAST is aimed mainly at QA or the QA phase. Why? Because IAST works by running introspection. Basically, it runs together with your run live application, and it does tracing of which requests or which operations or which functions in your application are being ran. And then based on that, it will generate the findings and all of the risks that it thinks that you have. So when you think about it, it sounds like the best of both worlds. You have the run live application information. It also does introspection, so it can point you to the code. The thing is that you also get the worst of both worlds. You need a run live application, but also you need to make sure that your IAST can actually introspect your code, which means it has to support all of those frameworks, all of those languages. And it also has to have some kind of initiator, right? Something that will cause the application to execute those requests, those functions, and let it run. So those are your main tools. And that's what usually you will find out there. Now, we're talking about the future of DevSecOps. So obviously, what we want to see, AppSec in the hands of developers. So we want to bring AppSec as close to the developer hands. For example, modern DAST solutions actually, and modern, I guess, SaaS solutions have the ability to really do deep integration into developer land. So, for example, modern DAST solutions might have the ability to do IDE integrations. They can run much quicker. You don't have to wait for stuff to really get deployed or run in the CI. And we can do even more push left. Auto-generate security-oriented unit testing. That's something pretty cool. So basically, you already have unit tests, right? You write your code, you add unit tests, you add integration testing end-to-end. Think about an application security solution that's going to auto-generate security-oriented unit testing. So that will be very cool. Full CI/CD automation. A lot of the things that we talked about is half there. So a lot of the organization, and I'm talking with many very high profile organizations out there. So not even top 500, I would say day to day, top 250, top 100. And they are not there yet. If we're talking about full CI/CD automation, there's always, this team does that and this team does that. This team uses a SaaS, but this team likes to use Elixir, so the SaaS doesn't work for them, so they're only using a Dust, and this team doesn't have the capability to run their solution in the CI, so they can't run a Dust, so they only run. So if we get to a place where we can do real full CI/CD automation, that is also going to be pretty amazing. Immediate feedback of detected issues, so bringing us fast remediation. So think about just running your line of code, or just, I don't know, save, or just git commit or git push, and bam, you have already information about, listen, there you just uploaded an issue, or there's a problem with your code, or get those feedbacks as fast as possible, and actionable results, right? So there is a concept that I mentioned before just in a bit, which is false positives. False positives kills productivity. It's a concept that we call alert fatigue, but basically, if you generate 5,000 findings, no developer is going to look at those findings. So we need to make sure that each finding that we generate is going to actually be actionable. It's going to be true, right? So this is part of it. So as accurate as you can get with the tools, that will be perfect. And that's about it. Thank you.
Okay, thank you, Bar. Very, very interesting. I actually learned several things, I can tell you. And guys, if you have any questions to Bar, please write it down in the Q&A. So Bar will answer all your questions. So we have several questions on the line. I will read it out loud. So the first one from Anonymous, if we were to start from nothing, what is the best next step after getting buy-in and collaboration with the developers and DevOps team? What will be the first steps, Bar?
So the first step in the sense of implementing new DevOps procedure, or in the sense of implementing new DevSecOps procedure? So if we're talking about
starting with the DevSecOps, I think starting with the tools, the security tools, what will you start with?
So if we're talking about starting a new DevSecOps process, I would say get the basics. So first of all, make sure that you have an SCA, because those are the quickest thing, and there's a lot of good open source tools out there. So SCA as first thing. If you don't have it already, put it into the CI. Make sure that no git commit or git push can actually be passed without software composition analysis, without package analysis. So dependable if you're using GitHub, or you have a lot of options out there. I would say that the second thing is to try and get a Dust solution running, and that's because you want to at least see what you have in runtime. And SCA won't be able to tell you what you have in runtime, and SAST also won't give you the ability to see what you have in runtime. So get a Dust. Then, I would go with maybe SAST, infrastructure as code, and container security, depending on how your application looks like.
Okay, interesting. So Bar, as I understand you, it's like the DevSecOps, it's like a defense in layers. So you're building several defense. If someone will be broken, then there is additional layer that will protect or reveal security defect. Is that correct? That's the approach?
So everything about security is layers. As we all know, security is like onion, and we take into consideration that at least a few of them are going to get breached. So we want as many layers as possible to make sure that we catch it somewhere. I would say that in the case of DevSecOps, is more about making sure that you cover everything. I guess it's also layers, but it's a coverage kind of situation. So we want to make sure that each part of the application, and that means third-party packages, source code, infrastructure, and also like the operating system that we're running our software on, so container security and runtime, so Dust. So we want to get all of this large view available.
Understood. Okay, so Mohit is asking, a very serious question. Why is it called DevSecOps and not SecDevOps? This is a historical question, so if you can highlight this.
That's actually it's a it's a funny question. The point is to put security in the middle, right? So that was the idea. So it's like you take dev, ops, you move them aside, put security in the middle. That's basically why.
Connecting between the ops and the dev.
Exactly.
Understood. Now it's clear. Okay, Dennis is asking, what about external libraries? I assume he's talking about third-party components. He's saying like you cannot be 100% sure that those libraries have no vulnerabilities in the process. How could you be sure of that, Bar? What is your...
This is exactly why I said SCA should be your first stop, because software composition analysis, or SCA, looks at the third-party code. At least on your code, you can do some kind of evaluation. But the code that you take from someplace else, that's the riskiest part of your code, because you are never 100% sure what there is inside, which is why you should put SCA as the first thing. So that makes sure that your packages are up to date and have no known CVEs.
Okay. Okay, interesting. So there is another question. What is your take on eliminating issues early on using strong SAST? Will it reduce the effort spent in the right side of the, I assume in the CI/CD, not the or the SSDLC?
So the obvious answer would be yes. The problem is that SAST solutions have a lot of tendency to generate a very large amount of false positive because of the guesstimating that I talked about before. And that can cause alert fatigue and a situation where your developers just doesn't believe in the tools. So even if you go with SAST, I would say use a Dust solution or a runtime scanner to validate the result of the SAST before you give them to the developers, because otherwise your developers will say, you know what, we can't handle those 10,000 findings and it's not actionable. We need to make sure that everything is developer friendly, and that means the least amount of noise that is possible.
So you are considering SAST as something that make maybe more noise if we are comparing it to Dust? Just for
that, yes, because Dust has the possibility to actually do validation. SAST, when it finds something, it will at best say, you know, we have so let's think for a second how it works, right? So we have a code, we have a function. This function called save data to database. So we take some value and save it in the database. Now, we don't know where this value came from. It could have come from an internal microservice. Maybe it came from a user. Maybe we already did a sanitization in another function or another microservice on this data. The SAST can't know it. It can't get the context and full view. And that's why the SAST will say you have an SQL injection here, but then the developer will tell you, no, there is a full microservice we have which sanitize all user input. So here can't be an SQL injection. And in this case, Dust just won't trace it because it won't find it. It will try and attack the entry point, see that there is no SQL injection. It will just won't waste your time in that case.
That's reasonable. And of course, very, very straight looking forward how to mitigate the risk. And of course, it's coming from best practices and common knowledge as you are familiar with the companies that you are working with. Okay, so there is another question from Dennis. Dennis asked us to imagine you did everything perfect in terms of DevSecOps. You publish your apps in production, and then suddenly you found data leakage. What would be the steps to fix the bugs? So stop production until the bugs will be fixed, or hope that nobody will know the problem? Like, what are the best practices as part of the, the DevOps team, the DevSecOps
Yeah.
approach?
So I would say that usually the CISO of the company will need to do the evaluation and decide on what should be the right approach. Obviously, hiding the problem is never a good approach, but most likely taking down production to fix a security issue is something that no one does. So that's the power of DevSecOps, right? So we find this problem in one of the steps. Now we know that it's also in production. We have a very quick way to just send an update, test it through, and deploy it. And that can be, a Docker image update. That can be an automated deployment script. But we have the ability to do those fixes very quickly and get into a situation where it's not a big deal to update, to do those rolling releases, those live updates. I saw a lot of cases where companies just will, hotfix those things. And it's like, I have a critical issue in production, we're just going to hotfix it. So it's like 2 hours and it's out because we have all of this automated testing, automated verification, and Git ops in a lot of cases that allows us to do all of this workflow automatically.
Mm-hmm. So take into advantage the DevSecOps approach, the DevOps approach, to go to production very fast. And I think we as a security professional need to understand that we can take it into our advantage and to fix security issue very fast. I saw it happen. I saw there are lots of security risk and security defects which is found. We always try to find them before production, but most of the time, yes, we find security defects, which is in production, and now we need to handle it, fast deploying it. There are some security risk mitigation that you can do from application security point of view. This is also some aspects outside of the DevSecOps. You can also deploy it like a web application firewall, a WAF, or some other mitigation or control in order to mitigate the risk until you fix it, testing and fix it, of course. But this is approach that the industry are going to, and I can see a very fast deploying of security defects. So of course take into consideration also
DevOps for the win.
Yes, that's what they are doing. Barry, in your day-to-day work, are you working with the DevOps team, more DevOps team, or more R&D teams? What are the
so in our company, those teams are actually all under R&D. So R&D also encapsulates DevOps. So DevOps and development will always work together. We have like engineering and DevOps, and everything we do is somehow combining most of those both of those teams. Now, I don't know, something cool. So for example, our company needs a lot of practice targets, right? To test our solution, to see that it finds all the vulnerabilities that it scans. So we need a lot of targets very quick. So with that, how do we automate getting practice targets up so that we can test them and, in an automated way to put it into the CI/CD, because you need to spin up, for example, Juice Shop. You need to spin up broken crystals. You need to spin up all of those vulnerable applications to do those tests against. So our infra team or DevOps team basically said, you know what, on us. So they created this awesome bot in Slack that we can just tag, ask it to spin up whichever application we want, and now it's part of the CI, and it's amazing. And all of the developers were like mind blown, because before they had to start running Dockers or asking for VMs in AWS, and this is the perfect example of how this infrastructure team or DevOps procedure actually brought infrastructure to say, let us help you, to the developers, and the developers can now run in a much quicker pace thanks to that.
to fix security issues.
Exactly.
Right. Okay, it's all about solution. It's all about solution.
Exactly.
And I think I can see in the day-to-day that the DevOps team is a team which can assist to implement security better in the pipeline, in the development process, because they are actually managing the tools. So they are managing each and every steps in the pipeline. They can insert security tools as part of the pipeline. They can give you insight because they are technical guys. So together, you can build the right solution for you. Take out of the shelf, don't invent the wheel, but integrate it in your CI/CD, do the fine tuning, and of course deploy it accordingly. But thank you very much for very insightful lecture and answering all the questions. Thank you very much for that. It was very insightful. So